Yeah, so that's that. But let's look at for the actual question, straightforward. So here the mean is 28, the standard deviation is 3. So if you want to say one standard deviation around the mean, that will be plus or minus 3, right? So 28 plus or minus 3 will be 25 to 31. Does that make sense? That'll be one standard deviation. Two standard deviations, you add another standard deviation, so minus 3 again. So 25 becomes 22. And another standard deviation on top, so 31 becomes 34. So 22 to 34 is actually plus or minus 2 standard deviations. So in the Chebyshev's rule, all we need to do is just to plug k equals 2. Where is it? Sorry. Yeah, so k equals 2. So that'll be what, 1 over 4, right? So 1 over 2 squared, 1 over 4 is what, 0.25. 1 minus 0.25 is 0.75, right? So at least 64% of the data, at least 60 observations lie within the interval. There are almost 40 observations and 95% of the observations. So who wants to try? What would the answer be for this one? Any attempts? Roland, please, go ahead. Jumoke, is it really optimal to have everyone muted though?
Oh, yeah, I did that because of the person
background noise.
that disrupted the class earlier.
Okay. Sure. Okay, let's go. There are 2 hands raised.
James?
Yeah, please go ahead.
Okay, sorry. I thought you wanted to speak. So I am inclined to say it's 95% of the observation lie within the interval.
That's number 2?
No, that's
or number 3.
Yeah, number 2 question, right? I think that's what we're talking about.
Yeah. So, like, are you saying what the answer will be?
Yes. Because we use the second standard deviation, right?
Yes. So 2 standard. Yeah, exactly. So 2 standard deviations. So is the answer at least 64% of the data lies within the interval, or is it
that should be number 4? Number 4, 95%
of the observations lie within. Okay.
Yes.
So if it were a normal distribution, that would be the case, right? So in this first case, remember the question says, what's the percentage of data in a standard normal distribution, right? So in this one, we're using this curve. But Chebyshev's rule is just an extension of the same idea to other distributions that are similar but not quite bell-shaped curves, right? So that's why the hint in the question is to use Chebyshev's rule. So while what you're saying is correct for a standard normal distribution, the hint just says use Chebyshev's rule, just to test that we're able to apply that rule of thumb, right? And what Chebyshev's rule says is the percentage of the data that will lie within k standard deviation is 1 minus 1 over k squared. So first, we've come to see that the range we're given is within 2 standard deviations, so k equals 2, right? So if we plug that, that will be 1 minus 1 divided by 2 squared. Dorcas has a question. Jamaica, could you unmute
Yes,
Dorcas?
please. Yes, please. I'm unmuted. Thank you. Good afternoon. Oh, no, sorry. Good evening, everyone. Yes, I think you've answered my question now. I was wondering where K became 2, because that was really confused me here. I was thinking that standard deviation is taking it at 3 to be 3, so I had 71 points. So I realized my answer wasn't within the range. So now I'm clear that these 2 figures now represent our K. All right.
Exactly. So K is 2. Now, yeah, so I use 3 intentionally, like, so that it's a bit tricky, but the K value is not the standard deviation value, because remember, your standard deviation could be 50, could be 1 million, it could be, depending on what numbers are in the distribution. It's just the range you're considering, you're trying to check is how many standard deviations wide. So what this 22 and 34 stand for will be this. So in this case, for example, this 70 and this 130 is what that 22 and 34 stand for. So let's say this mean, instead of 100, is 28 in that question. So, and the standard deviation is 3. So 28 plus 3 is 31, plus another 3 is 34. So the 34 mark will be here. And likewise, 28 minus 3 will be 22. So it's 2 standard deviations away. The shape of that one may not be quite like this, right? So that's why we're using Chebyshev's rule as a close approximation. So the answer here will be 1 over k squared, 1 minus 1 over k squared, and k squared is 4. So 1 minus 1 over 4. 1 over 4 is 0.25. So 1 minus that is 0.75. So in other words, 75% of the data lies within this range. Now, remember, all the total number of data points in our sample is 80, right? So 75% of 80 data points would fall within this range. And so 75%, that's just what, 3 over 4. And by 80, that would be 60. So that means you have at least 60 observations lie within this interval. Exactly. Perfect. So that's how to. So what this just does is, if you have a distribution that you know might be normal-esque, looking like a normal distribution, but not necessarily a normal distribution, you want to have a rule of thumb to quickly approximate, where would the data fall? And you have, the mean of the data and the standard deviation. You can always compute those anyway. So with this rule of thumb, you can have close approximations to where the majority of the data falls, depending on the number of standard deviations to the left or to the right? So that's the whole idea of this. Yeah, what's the other question? So what type of skewness is this, the distribution in the picture? It appears it's just a handful of people that are really following along. So this right skewed, correct? Once we're coding next week, we're doing SQL, you're going to really have to be hands-on, right? Because we have to follow everything. So it's right skewed. Describe the mean relative to the median. So what's the feature of a right skewed distribution that looks like this? Is the mean greater than the median, or is the median greater than the mean? Excellent. Thanks, Cynthia. Someone said mean question mark. Okay, mean is greater than median, greater than mode. Okay, I think that was a typo. Yeah, exactly. So where we're getting that from, to those that are asking, is this. So this right-hand skew as well, and you can see the mean is greater than the median. Same here. So that's the idea, because the data is skewed, so you have large values that are on the right-hand side of the distribution, and they pull the mean towards it. Now, something important to note is the mean is much more sensitive to outliers than the median is, right? And what do we mean by that? So imagine if you had a distribution of 10 numbers, right? And all the numbers were less than 10. 9 of the numbers were less than 10, and then you had one outlier, one large number. So we have 4, 5, 3, 1, 7, 8, 8, 9, whatever. 9 numbers. And the 10th number is like 50,000, right? The mean of those numbers is going to be really high, right? The mean is going to be really close to, going to be way out of the range of the 10 numbers, right? It's going to be 50,000 plus all the other small numbers, which may add up to 15 or less than 20, and divided by 10. So the number will be really large. But the median, what's going to happen to the median? Remember, the median is the middle number. So if you arrange them in ascending order, Your median is going to be what? The average of the 5th and the 6th position in the data, right? So whether you put 1 million on the extreme end or 10,000 or 5 or 0, once you're arranging it in ascending or descending order, the numbers in the middle are not really going to change for one outlier in this scenario, right? So that already hints that, you can see that the mean is much more responsive to outliers. Outliers impact the mean much more than the median, because the median is just that number in the middle, just telling you the midpoint of the distribution, such that the same number of data points on one side of the sample as on the other when you order them, right? So if you're dealing with data where you're unsure of outliers, one good way to have a good measure of the center of the data will be to use the median. So just to put that out there, in terms of sensitivity of those two statistics to outliers. What's the other thing in that our case? So we've answered this. What measures of center and variability are adequate for the data? We know this. So the last one, botany students of a class keep records, right, of height and centimeter of plants for an experiment. What measure of center and variability best describe the data sample? Anybody? Anybody? Does anyone have any thoughts? Like, you have it provided. Can anyone, you can just unmute or raise your hand and say a few things about it. You have a box that has a couple of statistics on the distribution. So just want to be sure we know how to read these and we know what the numbers mean. So this is good descriptive statistics. How many elements are in the sample? How many measurements did they do? Is there or is in the box? Because many simple statistics software give you this kind of box with different statistics that have been measured. And that's exactly what you have here. This is probably from a software called JMP. It looks familiar. Anybody? Anyway, you can see N, so it's 20 measurements. So they have 20 plants heights. The mean is 51.05, so somewhere here in the middle. The mean will be here. The standard deviation is 10.63. So one standard deviation around the mean will be around 40 and around 62, right? So you can already see one standard deviation around it. You have the bulk of the data falling in here. Two standard deviations, you're down to 30 and up to 73. And you can see that's already most of the data. The maximum is 75, minimum is 32. The median is 50. The median and the mean are really close. So it's a very symmetrical distribution. And you can already see that even from this histogram, right? Yeah, so there's one last thing that shows Q1 and Q3. Do you remember what those are? In the chat or raise our hands. Come on, guys, give me feedback. Q1, Q3, do we remember what those are? The quartiles, great. So this is the first quartile, third quartile. The interquartile range would be this minus this. And that would be around, what, 15? Yeah, 15 precisely is the interquartile range, which would be Q1, the difference in Q1 and Q3. So yeah, that's that. Pretty straightforward stuff. I shared, I don't know if it's on your Slack channel yet, but there's an example that I wanted us to take a quick look at?
Yes, it is.
Okay, so you can go to the Slack channel. You get 2 set of questions and 2, I think they're CSV files or Excel sheets that just have some data. Let me pull them up. We'll do one in class and take the other away. Has everyone been able to get the questions? Please reply with like a thumbs up, or if you need a few minutes to go to Slack and like download it to your computer, please do. Like today is a lab class on the schedule, so everyone should be with like their computers and like be following along. This is not like a lecture today. Is that the sense that I have? Do most people have their computers with them? Are we just watching or waiting for the videos? Jumaka, is it because people are unmuted that I'm not getting sound feedback?
They are actually allowed to unmute. They can unmute.
Okay, please, you can unmute, or you don't have to just type.
I think we've been conditioned to that, so subconsciously we are used to it that we don't talk during class. Sorry about that. Yeah.
No problem.
So that's why everybody's quiet. Sort of. It's not intentional.
Okay. Please, in this class, talk to me like this. Yeah, in this class you can talk, you can unmute yourself, and just remember to mute yourself back, like if there's noise in your background. Otherwise, we're good. There's some typos in this thing now. Okay, so just take a look at the questions. I'll give us like 2 minutes to just open the file on the Excel, open the ABC Fitness one, and we'll just take a quick look. Then I'll leave us to attempt it, and then it's like very straightforward stuff, right? And I know many of us like use Excel for all sorts of things, right? So for those that actually use Excel, like you may want to, I don't know if you want to go along, but very straightforward stuff. But we should all click along like once we start. So everyone has the questions and has taken a look, and everyone has the data as well. Am I correct or not? Please, is that an assignment? So yes, like I'll touch on parts of it, but it will be up to everyone to go back and finish it before next class. And there's this data set, and there's another smaller one on World Cup data. So I'll give us 1 minute to just get the Excel open just like I have, and the Word document open, and read the problem statement already. And then we'll continue discussing it in a minute. Yeah, so are we all good? Okay, so let's go. So it's just a small data set, just, finger exercise. Thanks, Dorcas. Just finger exercise. So the question is saying, Pure Consulting, right? They're assigned to identify the profile of typical customers for a fitness product offered by ABC Fitness. So ABC Fitness is a company that has fitness products. So this is like a market research data set. And essentially, the team collects some data, and this is the data here. So metadata is just data about the data, right? So information about the data. So whether about variables, the data types, and whatever else. So it has a couple of fields: the product, gender of the customer, age and years, relationship status, annual household income. A couple of things. Let's look at it in the actual file. So here we go. This is the data you have. So I just froze my first row. I recommend you do that when you're just going through it. So you have the product, and there's a product code. You have age, you have gender, marital status, usage. So what's the usage? Number of times a customer plans to use a treadmill each week, right? Then there's average number of miles the customer expects to walk or run. So the product is a treadmill product. And the last is self-rated fitness. So the fitness of the customers, where 1 is poor and 5 is excellent. What kind of data is this? Ordinal, right? So here, even though this is like numerical data, like what the data is speaking to is a ranking system for people's fitness, right? Where you're going from 1 to 5. So you see how even data that is numerical can be used to as a representation of something categorical, right? So this is saying fitness levels, level 1, level 2, level 3, up to level 5. Right. So there are a couple of questions, but beyond that, there's just another open-ended question to see like what you can do with the data. So I would assume everyone has finished questions 1 to 3 at least already. So does anyone want to share what's the range of income and what do you notice about that? Anybody? Oh, we're not there yet. We're still setting up. I'm just waiting for who has the range for us. Take this away. Anybody? Are we working on it? Okay, so the first question is asking for the range of the income. Right, so someone said the range is this less this, which should be what? So 70 something? So the range is, sorry, my keyboard is, like I'm using Parallels Desktop, so my keyboard might be. So this is the minimum, right? Minimum income. Is that 331,000? How did you get 31,000? Do you want to share? Like everyone can unmute and just like talk through what they're doing.
Oh, sorry, that was a mistake. I just saw 29.
Say that again. I think there was some feedback there when you were talking. So the range.
I was saying that was a mistake, that I just saw the 29. I was looking for the minimum number and I didn't see 29.
Okay. So you did it like visually, right? Like you just inspected it.
Yes.
Yeah. So you don't want to be doing that, right? Because like you know, it's good you actually did that and shared, like, right? Because you want to use like inbuilt functions that make your work more accurate. So the range is just the mean minus the max. And to get the mean and the max, like we're using the mean function and the max function. Exactly. So the difference there is, so I'm assuming like a lot that like we've been using Excel. So like if you want me to just like show how you did this or show how you did that, like just say that and I won't just glide along, okay? So this is the range. Exactly, max minus mean. So this is the range of income. So this is the income range, right? Between our lowest income customer has 29K, highest range, highest income is 104,000, right? So that's a wide range of 75,000. So showing how I did it, I just did minimum. So min, and you put the range, and it's going to give you the minimum within that range. Same with max, and the range. And the difference between the two is your range, right? And then the question also said, like, make some comments on the range, right? So does anyone have anything to want to say about the range? It's quite a large range, right? So if, like, at this point, it's just left to your creativity, right? You could say, I'm sorry. Yikes. Sorry, I'm using Parallels, so my keyboard is kind of a mess. So this divided by this. So, right, we have someone, the highest person earns almost 4 times the lowest person's income. So we have a broad distribution of incomes. Another thing we can do, right, is to even show in a histogram the distribution, right, for the different. One sec. Histogram. Okay. So let's answer the next question first. And I'll show us a few things, trying to recreate the distributions we've been working with so far. So the next one is find the mean, median, and mode of the numeric columns. and list 5 observations drawn from the descriptive statistics of the data set. Really straightforward. So to get the mean, remember, you can always refer back to the slide. The slides have the Excel equivalent of how to do lots of the computations from mode to quartile to median to the arithmetic mean. So it's all there. So you can always reference it, right? So if we want to get the average income, we're just doing average, and then you're selecting the range, right? So if you want to go all the way down, you can just hold Control and Shift and the arrow down, enter. So this is the average. This is your average. So this is your average income, right? 49K naira. So does anyone want to tell us what the median is? Median, anybody? This is just to practice like the things from our slides. Very straightforward stuff. Is there any step that we missed? Does anyone have a question? Okay, the median is 4617, good. What's the next thing? Wait, let's stay here. What's the mean age? Mean age. Anybody? Age. $27.8. How come we have three numbers? What's the actual answer? So answer 28. Okay, let's mean
The
age.
geometric mean is 27, 28, and the average, which is also the mean, is 29.
Yes, in this case, we'll be using the arithmetic mean.
Okay. So that lies in the challenge. Now, the mean is almost equivalent to the average in this case.
Yeah, so this is what the mean would be. So the mean here is the average. The average is your arithmetic mean, which is just the sum of all ages divided by the number of ages there are, which is 278 entries you have in this data set. So that will be this number, right?
That's 29.
Yes. 29, 28.6. Yeah. So back here, what else do they want? So now something to practice, which, well, because of time, doesn't matter as much, but just how to present like your work in Excel. So that's why here I said, give me the statistics for all the numerical columns. So like when you're doing it, the rest of it for the assignment, you can like put in some nicer form, right? Like put the metrics and then put the average, put the median, like make it look sharp. So in your Excel, do you all have the data field enabled? What's the next question?
Next thing is mode, and mode is 25.
Okay. That's mode of for the ages, right?
Yeah.
Okay. So anyway, bottom line is that it's all straightforward. But let's just do some slicing of the data. Then you can take the rest like to answer at home. But I just wanted to show us the pivot table. So let's first highlight all the data. Let's go along, right? So you just highlight all the data, and the shortcut to highlighting all the data, if you come to this row, right, just hold Control and Shift and the arrow sign to the end and the arrow sign down, and you can highlight the entire range, right? And then if you go to Insert, you can insert what you call a pivot table. So pivot tables are really handy for slicing and dicing data, right? So I'll show us in a bit like how you can use your pivot table to slice the data in different ways, right? So does everyone have their pivot table created? So you click on pivot table. So when you click on pivot table, this dialog box opens and it just wants to get your table range. Now, if we had named this table, you can also use the table name, but for simplicity, let's just use the table range, and it asks you if you want to open it in a new worksheet. You say yes. You can also open in the existing worksheet if you want, but just for it to be neater, let's say okay. So here you go. So you have this window. Is everyone here? If you're not and you need me to repeat, just say so. I'll do it again. Otherwise, if you're here, good, because I want us to follow along and learn like how to use pivot tables. Is everyone there? Just give me a thumbs up so I know.
Yes.
Or if you need me to repeat, I can do
Please
that.
repeat. I'm not there yet. I can't even find pivot. Like I've highlighted everything, but I can't find pivot table. Sorry.
Okay, so when you highlighted everything, come to Insert. Insert is beside Home.
Yeah.
So when you come to Insert, you can even see recommended pivot tables.
Yeah,
this gives you a view, but okay. So when you do that, you'll be in a new sheet. Now the pivot table on the screen, you can see a couple of boxes, and it's saying drop row fields here, drop column fields here, drop row filters. So the way pivot table works is it allows you to slice your data into rows and columns, right? And you can put different summary statistics within the table, and you can also filter. So if you slide over to the pivot table fields on the right hand, is everyone here on the right hand side? Okay, so once you're here, right, you can see in the first box, you have all the different fields within your data. So we have product, age, gender, and so on. Down here, we have filters, you have columns, you have rows, and you have values. So for my first view, let me try to filter, show some data, slice the data by product. So I click on product, and I drag product into the rows table. So if you see on the right hand, let me zoom in a bit. Can you see? So it has put all the unique product codes on the right hand side. Is everybody at this point? So now you have product, you have the different product types, you have grand total, and you have a filter flyout here. So all good. Pivot tables will really help you be able to, at a glance, do lots of interesting slicing with your data. So it's really important that we follow at this point. And I hope I have like everyone practicing. Cynthia, are you on the same page with us? Jumoke, Adenola. I just want to be sure all the people that are following closely are Udwak, Roland, Nelly.
Yes, I am. Thanks.
Okay, ID. Okay, so now we've put what product. So let's say we want to count the number of products by product type that was bought, right? Remember what your data looks like is this. So you have the different product each customer bought and then information on that customer, right? So we can go back to our pivot table and we can drag product once again, but this time we drag it into the values column. And you can see what it shows. If you read this, it says count of products. So it's telling you how many products for each product type. So what we've done here is we've sliced product by product type. We've sliced the data by product type and the count of each product type. So already at a glance, we can see that what you have 80 of one SC195, 60 units of 498, 40 units of this, 98 units of that. So you see how at a glance, we're able to just quickly show a view with the data. If they asked, oh, how many 498 SC models did we sell? In a meeting, you're in a meeting, you can easily just pull your pivot table and start slicing your data and coming up with the answers as they're requested, right? Does that make sense? Now, how many SC195 products were bought by female customers? Let's say we're trying to know what the percentage split is, right, between men and women in our customer base. Remember, ultimately the goal here is we're trying to profile. This is a market research endeavor, so we're trying to profile the customers, right? We're trying to collect data on individuals who purchased, right, for our market research goal. So always keep the business objective in mind, right, as we're playing around with the data. Okay, someone said 40, right? So how did you slice the data, Devon? You did it with your pivot table, yes?
Oh, sorry, what was the question again?
Yes, I did it with the pivot table, or just the gender. So
Okay.
that would now divide the that total count to male and female.
So where should I put the gender?
The gender will be in filter.
Filter, okay. So you can put in filter and then.
Sorry, I had my gender in column. Does it matter?
If I put it in column too, it will do the same. It will give you in column.
Okay.
So if you want to see both, you would have it in column. Ideally, I would have put it in column, but I wanted to just show like that there are different approaches. Another thing you can do if you want to have percentages, you can also change. If you come to value fields, you can also change what the data is being shown as, right? Mm-hmm. So you can put as percentage of row total, and you see it gives you as percentages. Does that make sense? So it tells you what the percentage split between male and female is. Did we get that? So it tells you 48%. So for SC498, you have 48% female purchases versus 52%.
Sorry, please, I didn't get that. How did you do the percentage?
Okay.
No,
so you just go to count. So just remember how the pivot table works, right? You're slicing along columns here, slicing along rows here. Here you're putting the values. So the values you're showing within the table. Now, if you click this flyout in values, you can go to value field settings. So here you have lots of different settings, right? If you don't want to do count, but it's a metric you can sum. In this case, we drag product. Product is categorical, so we cannot sum it, right? Remember our data types. Product here is these codes. So you cannot sum the codes. There's no point, right? But you can have count, right? So here you have different summary statistics you want to put here, like standard deviation, all those descriptive analytics statistics we looked at. Look at them, they're here, right? Summaries. Then there's also something else to show the value as. So for the same count, how do you want to show it? You can show no calculation, which is what we had before, right? So this is just the actual counts, or you might want to see the percentage counts. Let's actually make that as another pivot table. Sorry. Control C. Right, so let that be another pivot table. So once again, we just go to values, value field settings, go to what you want to show it as. You can calculate as percentage of the row. So you want it as percentage of the total on each row, and that's what you have here. So here you can, at a glance, see if they say what product has the lowest female uptake, right? Female customer uptake from your market research. At a glance, you can already see that with your pivot table, and that will be SC798, right?
Thank you.
Yeah. In the same way, let's see. You can also put filters. So filters here work on, so for the same visual, if you want to filter it, and let's say we want to say, Deborah has a question. Yeah, go ahead, please.
Sorry, when you were choosing percentage of what did you choose?
Of row total.
Of row total.
Yeah.
Okay.
And you can also, if you want a different view, where you want to know, so for among all the female customers, right? Let's see the distribution of like percentage splits for the different products, right? For all the females. In that case, what we'll be doing is, instead of row total, we'll be doing of column total, right? So now you see the total of 100 is now at the bottom, right? So what we're saying is, of all the different treadmills that female customers bought, right, 33%, the SC195, or rather the SC850 and 195 are most popular among women, and the SC798 is least popular among women. So in this case now we're doing as a percentage of the column, right? So if your total number of women is 121, only 10 of those were this model bought by female customers. So you see with the pivot table, you can start already getting some interesting descriptive statistics by just slicing the data, just playing around with the data, right? Hope that makes sense. Okay, then I was showing filters as well. So let's say we want to see, if you want to filter selecting multiple, we don't want to see, we just want people that are below less than or equal to 40 years, right? Right, we don't want these guys. And there are advanced filters where you can put in a range as well. So 140 years or below, and it shows you the same analysis, but just for people within that age range. So you can put lots of different filters depending on what you want, right? We can take out this filter. And take out this age filter. Let's say we want to filter on marital status, right? We don't care about, there's a new product we're launching that's partner running. So we want something for couples. I don't know if that makes sense, but anyway, we can filter out all the single people and we have only partners, people that are in partnerships, and this is how the distribution readjusts. So you can put lots of filters. You can put many filters at the same time. Still going to work. So you can filter on multiple variables. ID, please go ahead. ID, you can unmute. Your hands are raised.
Sorry, I thought I was unmuted. Could you show how you created the pivot table within the pivot table again, please?
Oh, for the second one?
Yeah.
Oh, I just copied and pasted the first one.
Oh, okay.
But
okay.
if you want to do it, like another way to do it would be to come back to your highlighted data.
Yeah, and create another pivot table. All right.
Yeah, and just insert, but this time you insert in existing worksheet.
Yeah.
And it's going to, yeah, okay, it's going to ask you where, and then you just go to
exactly.
table. Okay.
Okay.
Okay. So there you go. So let's see. Let's look at data and try and see. Let's try and see some other things. Let's look at income a bit, right? So let's say we're income and what's this usage thing again? How often people use? I'm just curious, since we have income and marital status, let's check income. No. Income for, so this is the total income, nope. Income by marital status, right? So this is income of single people and married people. But that number it's not really meaningful as a sum, right? Like if you're adding, that would just depend on how many people are married versus single. So you most likely want to use an average in this case, right? So you want to know the average income among single or partnered people. So partnered people have a slightly higher income, right? We might want to slice by gender. Just put that in columns, right? And then you can see the average income. Remember when we looked at the cross-tab analysis, right? So pivot tables are a very handy way to do, where is it again? Remember this picture? Snap. I was in the other class, yeah, this guy. So you see, this looks like this pivot table data, right? So with a pivot table, you can also easily like show different views and slices of your data, right? So just to highlight that there. So I think at this point, like we know how to use pivot tables, like we can go wild on it and do different filters. So I'm curious to see what we'll be able to do like with the homework, right? To show different views, right, within the assignment. So do you guys want me to give us like 5 or 10 minutes and see what people are able to put together like with the same data and your slices? And like when we come back in 5 minutes, everyone will just share something like a new view they did. And then I'll get the actual assignments on Sunday. So before our Monday class or Monday afternoon, before the Monday class, so I can take a look.
Hello, Shekinah, sorry, before we go,
Yes.
sorry to take you back.
Okay.
Yeah, on the break here. I don't quite understand how you got the average income. Did you copy and paste again this count of products, or you just started
So there are two
you
ways
just
we
click
did
on
it.
any area? Right.
Like if you click on an existing pivot table, like you're going to have this pivot table fields. Is that what you mean? Or do you mean how we created the pivot table again?
How you created this one, the arrow is.
Right. So you can either copy and paste this. Oops. You can either copy and paste the same one, or you can like go back to the data and create a new one. So if you come here, highlight all the data, you can do insert, but this time instead of on a new sheet, you can just go to existing worksheet. And then you click that arrow and you go and put where in the worksheet you want to put the pivot table, enter. So it just creates the pivot table there. So that's what we did. Or you can copy and paste an existing pivot table, then change the variables. You can drag and throw away the variables and put what you want, what you're interested in seeing.
Thank you so much.
Yeah. Okay, so I'm curious to see what you guys are able to slice around and think about it relative to a business problem, right? So go back and see, okay, you're trying to understand your customers. From that small data, like what can we say either about men and women? Look at this fitness and usage. We haven't used these fields a lot. The usage is just the number of times a week someone uses their treadmill. So is there something that will come to mind now? And I want you guys to come up with your own ideas, right, on the business problem. But something that comes to mind is, so is there any bias in terms of high usage for the different kind of products? So maybe there's a product here that is really like for professional runners or for athletes, and you'd see those are people that have high usage. or the fitness level? Is there a preference or a tendency for people with high fitness to buy one of the equipment versus people with, that use it occasionally and are not very fit? So you can start doing that kind of slicing to see what you can learn. Remember, this is a market research question. So what you can learn about the market research data you've gathered. Is there any of these models for which very fit customers tend to have a preference for, things like that. So I'll just give us a few minutes to think. Just come up with one idea or one thing, one view you want to test. And when we come back, I'll just ask around, and I'll package the rest as the homework and everyone will try and do that by Monday. And then we'll start doing like some more heavy lifting, like learn SQL. I'm trying to rush us to start the SQL class early. And if we have time, I can throw in some more Excel, like when we're working on the project, just so that we have like more time to spend learning the SQL. Okay, so let's go 5 to 10 minutes and we'll be back to wrap up the class. 2 seconds. Yes, please, Udrak.
Hi. So I found that the 25-year-olds, and they are the mood, they are the most, so they make up like our mood, but they are the ones with they are the ones that buy a lot and they have good income, and then like they rate highest in like the fitness and usage, and the ones that are really rich buy the 850 model.
Okay, so a lot of data. So you said what age group was that?
Age 25.
Age 25. What are the things you said? Fitness?
Yeah. Fitness, yes.
So we can say average fitness.
Sorry, where do you get that small stuff where you can see percentages?
Which one? Is it for... So if you want to like show as a percentage of the row, right? Is it that one? You just go to, 1 second, you go to...
Oh, up there, okay. Wait,
no, you come here. To see it as a percentage of the row, you come to show value as, and then you can put like what value you want. 25-year-olds. What's the other thing you said? You said they were fit. I see some other ages that are fitter than them, though. What's the other? There's something else you said about.
They like the 850 model, the SC 850 model.
Okay. Okay. To do that, what we can do is we can take out fitness first. I can put models in the column. So product and product count. Right. So this was the one you were looking to make as percentage, was that it? There's somewhere to change this percentage of row errors. Okay, so we said they liked 25-year-olds. Okay, why I'm not filtering it out is because I want us to like see if there's anything remarkable about them compared to others. So 25-year-olds seem to like one model now. The SC850.
I can help out with my own data. Give you more
I think I
information
can
about
also
it because they are very interesting.
Right.
I think I can also speak to the 25 years. That's
okay. What's it about them?
one, they have the highest income on products, and that's SC 850 is is the product they spend their highest on.
So
Of all
did you say they had the highest income?
on products, that they spend on products, their income by products, they spend 761,211.
Because income has to do with like the person, right? So how much the individuals in that group, how much they earn.
Oh, sorry, I think.
Do you get what I mean?
Sorry, let me check something. I think I filtered. Entered some other filter.
Okay. In this case, you want to do average, right? To get average income. And I'm not sure like their income is more. I'm not sure. $25. Is anyone seeing anything interesting about 25-year-olds again? Because someone said noisy background. Interesting data. Only men attempted the 360 miles, and it was attempted by 35 on product days, and average fitness was 5. Okay, so when you say so this miles, remember the metadata. The miles is the average number the customer says they're going to run a week. So their average run per week. So yeah, the data is very interesting for okay, let's look at men and the average they run, right? Something interesting, like I'm curious to see is even men and women, like the average miles they run. So let's use this table. So if we had gender here and we had miles. And you want to see average run. So men run on average 12 miles more than women. Right, 11. What's the other conclusion said? So this 360 here, you're probably doing a sum. Remember, if you're comparing like behavior, you might want to do an average. And then what product is more popular among men? So once again, we can do that cross-tab analysis that has products. In which case we can do this and we can do count of products. Let me take out the average miles for now. So men run more and men tend to like the SC850. Another thing we can do is we can filter out men to drill down into like men, what men prefer, and look at the different products for men, but then look at fitness, right? So if we put the different fitness levels, let's filter out for just men. So we'll take out female. So males and fitness levels. Now, so these are the different fitness levels, 1, 2, 3, 4, 5, right? Fitness by product. Right, so let's do a percentage across percentage of the row, you see what I'm trying to do is to see what product is popular among the very fit people, right? So as a percentage of row total. So here we can immediately see that among the very fit people, right, which is 4 and 5, right? This SC, let me remove this. So the SC850 is very popular among people that are very fit, right? Compared to, so among people that are not so fit, the SC195 and 498 products seem to be more popular. You see it? Although the SC850 seems to be quite popular across board even, right? Just that it's, oh no, that's actually not accurate. Okay, you have these 3 products are very popular among people that are very fit. So if you were doing a market research at this point, you might want to start looking at, what is it about these products, right, that make it the case that, people that are very fit, like between these two, in this case, in fact, 97% of all the fitness 5 people use either the 798 or 850 product, and they don't care much for these other products. So the SC195 and 498 seems to be doing better among people of low to intermediate level fitness. So is it that this is a more pro product that probably has like inclined run, has a digital display for marathon, has more features for people that are really like athletes that are training? Maybe these are higher end models and these ones are not. So you can always, like someone said, the data is really interesting. You can slice in all sorts of ways. I'm seeing some other cool product. This is most used at 32.46%. Nice. It's a good catch there. Men having the higher income level also have the higher fitness level. Okay, so someone's saying males seem to be more fit. Let's see if this trend is the same with women.
And if you want to check based on marital status too, you want to filter that into when you're talking about segmentation in marketing, you would realize that the partnered, those that are married or partnered, are the one that make use of all the products in general. We have more usage with those that are partnered. Right. And you now filter with age alongside with that, you realize that some ages were the one that have most of, where they have most of their usage. So that's interesting too. You want to look at it from that angle too.
Yeah, that's very valid.
Sorry, please. If we still check that age, and if we income by product and age, seems to still be revealing that the age 25 years old is the one that is the one that spent more on the products. Not that they hand the highest income, but if you do income by product and age, it's revealing that
as a column like this.
Yes. No, income by product.
So can you check and make sure that you're doing average income and not sum of income?
Oh, okay. Okay.
Yeah,
okay.
So remember, and part of what we've been discussing so far is to know like what statistic to use. So that average makes it possible to compare within the ages. Because if you're using sum, then the data will just be revealing like what age group you collected more data on. So if, let's say you got this data by interviewing prospective customers, right? If you just happen to fall on many 25-year-olds, then when you sum the data in that sense, then their income looks large. But what you want to look at is the average within that group so that you can compare between ages. So anytime you're comparing, like you have to use a statistic that's standardized in some form. So like the average in this case will tell you, okay, you can compare between ages in that sense. Yeah.
Thank you. Thank you. That's the error. Thank you.
Sure. Yeah. So you see, it's really interesting, and particularly like I could have just given you some numbers and said, what's the average of this, what's the this of that. But with a use case, with a business problem, you start seeing, when you're going to get your data analyst job or on the current job you're doing, like you're going to be using these ideas, but using them to help you answer business questions, right? Not just doing them in the abstract. One other thing I would say, like to add to what we've done today, is make sure you have like a systematic way of approaching it. So when you're doing the assignment, like for those that have just been listening and we're not practicing, like you have these videos, you have different, suggestions people made and contributions. You want to have like a standard way. You can take down some notes. Like first, we want to slice by age, by this, by income. We want to understand the average income of our different customers. So we want to build like some customer like profile, right? We know average age within women. We want to build a distribution. And I hope you go back and you're able to do the distribution part. But we'll look at it like for like 4 minutes or 5 minutes, like when we start the session on Monday before we switch. But you would see the distribution of like the women and their income and their fitness. So you can, let's say your first step in your procedure will be trying to understand the demographics in the data and try to understand like what's the like slice the customer in different ways, right? Then the next step, maybe you want to now layer that on product. You want to look at the different products, who's buying the different products across the different segments you've created. You probably want to look at fitness versus product, look at income versus product. Maybe because here they didn't give us the cost of each product. So it could be the case that higher income people are being able to afford a certain kind of product, or is based on their fitness, like people that are like pro athletes are going for a certain product that's more advanced, has more features, right? So you start already drilling down and it starts making sense, but just try not to do it too randomly, right? Have like a method, make it systematic. Like you're looking at the different segments within the customer base. You're trying to link the different products to what you know about the customers, fitness, how often they're going to be using it. But always think about the metrics in your data in terms of what the business implications would be. Like, don't just say, oh, usage, fitness. What does usage and fitness point? Usage and fitness, what does it point to? It most likely points to whether someone that really is very active, someone that is a pro athlete, someone that is a casual user, right? And already you might see that people that are casual users may not want to spend too much on a treadmill. On the flip side, they may be very wealthy, very high income brackets, and they just want like a premium product, regardless of the number of times they're going to use it, right? So do you want to position one of the products as for the pro athletes and you're targeting people that are high fitness, high usage? Do you want a premium high-end treadmill that has like a screen with Netflix on it and people can listen and they can do lots of calls, just a premium product, whether or not they use it a lot? So you start thinking about how your product could be positioned within the market, which is the whole point of market research, right? So I want us to go back and try and look at these and come up with something nice for the assignment. And there are 2 assignments, so try and attempt both. Just one last thing you can do with pivot tables that I thought we could show would be, so under pivot analyze, you can actually put a pivot chart, right? So the pivot charts are linked to the pivot table. So in this case, you can see we have a composite bar chart that shows you like for each product, you have male and female. So at a glance, you can see this visual and makes sense, right? You can compare. So just looking at it, you can see that males are much higher. In the lower products, there's similar numbers. And much higher in this product. You can do same with the percentages. Remember, you're just going to pivot analyze, pivot chart, and you have lots of options of charts, right? Depending on what fits for the particular thing we're looking at. So this is the exact same visual as the first one, right? We can look at, so here we're looking at what age. So let's say we're looking at age and income. This is age and income, right? So the pivot chart just links to your pivot table and is able to show you like interesting things within the data. So It's just a line graph. Doesn't mean as much. Line graph showing age and average income. So there's not much correlation with of age and income in this case. But whatever view you're doing, ID, please go ahead.
You show how you can group the age in terms of visual. If one of segments the age bracket, between 18 to 20 and all that, I think I kind of like lost how to do that. Can't remember.
That's to create buckets, right, in your filter. Is that it? To create buckets in your filter?
To create bucket for the age.
For the age, okay. So I think to do that, we're going to have to create. To bin the age, I'm trying to. Wait 1 second. Let's move age to filters. I know there are two ways to do it. One is like doing it within the data, but you're supposed to be able to do it in the pivot chart. I've forgotten for some reason. I'll check it and just show it next class. But you can bin it usually, but for some reason, I'm not seeing where it is today. So another straightforward way to do it would be like with a histogram, but someone said we need Excel screenshots. But I'll check and show us, or just drop a message to Jumake and she'll put it on Slack. Sounds good. The alternative would be to like filter manually here, but there's a short way to, if I remember correctly, there's a short way to bin it directly without using a histogram, to filter in groups. I'll check. So like here I'm on Parallels, like I'm using 365. I normally don't use Excel 365, but I'll send something across with it. No worries. That's to have bins like age 25 to this to that, but to do it automatically, right? That's what you're saying.
Yeah, that's what I'm saying, yeah.
Yeah, okay. The alternative would be to have it manually as an extra column, right? Which is also easy to do. You can just with an if statement here, like we can say if age between this and this, then, and we'll put text. So what I mean is, if you say if, right, and you're just saying
that's the cheat way out.
Yes, so you can create an extra field that has, but that's like too much scenario. So yeah, the short form. Okay. Yeah, so let's attempt the assignment. Like maybe on Monday, I'll just put forth a few thoughts as well. Definitely, I'll show the binning as well. And what are we lacking? Yeah, but let's try and attempt both. Like someone said, the data is quite interesting. Just think about it in terms of the business as well. We've used pivot tables. They're very handy for slicing data and showing like cool views. And you can always attach a pivot chart to your pivot table. So whatever analysis you do, try and layer on it a pivot chart. Dorcas? And let's see what we have.
Yes, thank you. I was just wondering, the fitness, do you want it to be in average, or how do I put it? Is it better to do the analysis based on average with the fitness or some?
It depends on what you're doing. Are you comparing like fitness between different groups?
Gender,
Age or
between gender and then age, the fitness.
Yes, if you're comparing
That
across
age.
a slice, you should use average. Depends on what you're trying to do though, right? But yeah, average seems right. If you're like if you're looking at fitness between men and women, right? You want to use average fitness.
Thank you.
Yeah, thanks. Someone's hand is up as well. Do you have a question?
Hi, I was just asking, are we submitting this to you or this is just for practice?
No, we're submitting on on
So
Monday
is it
afternoon.
screenshots or you want Excel files?
An Excel file would be good, but just like tidily and with some notes. So usually, like what you would do if you're sharing this with someone at work, you could just like if you have this view and you have some insights you've gotten by the views you've done, you can always just insert a text box. This is what I do usually, and put, we can see that the blah 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 is this because this among women there's a 5% more, there's a preference for this as shown by women buying the SC 498 50% of the time, whatever. Like, so just a few comments and the analysis that supports the conclusions. That'll be a straightforward way to do it. You can make your background white just so it's legible, and you can have your bullets there with what you're trying to say. Yeah, that's a good question on how to present it. So it would be an Excel sheet, an Excel file that would have just the analysis you've done. You can just go on one sheet, make that sheet white, right? And then you can make that sheet white and then copy and paste all of this information, just if you want to have in one place. Right? So that's how I'll do it. So you can put in all this and then put in your analysis and the conclusions you made. Right? Does that make sense? Do we have any other questions? And this is due on Monday. So let's try, at least let everyone do something detailed from all what we've done in class today, from everyone's ideas. Just put it together in a way that makes sense. If you are a data analyst, you were working for a market research firm and this data came in from the market research they did, what analysis are you going to do around it? Are we supposed to capture all the data in the pivot table or just some? I'm not sure I understand that question. Do you mean like all your analysis should be based on all the data or any slice of the data you want, just whatever supports the analysis? But if what you mean is like, should you use only pivot tables? The answer is not necessarily. Like you can do the analysis in any way, just as far as it speaks to the question. And this is good practice because with the final case study, but it's just going to be more detailed than this. Like there'll be a database, you pull the data with SQL, you're going to present like your work with, I don't know, maybe a dashboard in Power BI or something more like business scale. But this kind of requests come in every day, like at work as well. So this is good practice. So let everyone try and actually do the work. And yeah, we'll see you on Monday. Is there any other question or any comment, any general comment on the class so far and like how we're learning, or any question about the assignment? Any questions?
We will be answering the questions on the text in the document and any other my thinking? Please correct me if I'm wrong.
Yes, but I mean, I just added like relevant insights. For me, the biggest part really, this may not be on that sheet. I think I sent an older version, but for me, this is really the big one, the number 6. Like these questions, honestly, is just a guide to do something, right? But they're really straightforward. The main thing will be what we did in class today. So what further ways can you think about the data, slice it, and come up with, read, the question again, the background, and you would be able to think about, what other ways you could view the data. You saw there were lots of great ideas from the class today, like people saying, oh, there's this age that kind of stands out because of how they're doing. There's, when you look at gender and you slice fitness, like women that are very active seem to like this product. So maybe your recommendation would be to, try and do some focus group to figure out why, right? It could be men that have high income, don't care, regardless of their fitness, they just want this particular product. Maybe there's a feature there in that product that, rich people like. Maybe nice big display and you can watch Netflix, or the build is premium, or other ones are plastic and that one is like a stainless steel body. Like it just starts bringing up all those questions, right? And then depending on how you slice it, you can come up with something fun and interesting as an insight and add to your assignment.
Okay, thank you. Sorry, that's question 6. Please, can you show it? It's not part of the one.
Yeah,
So
it's just whatever other relevant insight. So essentially what we did in class, like, is just do 1 to 5 and more. And more should be like more than the rest, if possible. Yeah, so just whatever other relevant insights you can deduce from the data, given the techniques we saw in class today and what we've been seeing so far. Yeah, so all good. Yeah, if we're good, we can call it a wrap. So next class, we'll just go over the assignments, like look at what people did. Please try and like send it in early on Monday so we can take a look. So we'll try and see what people did. And yeah, we'll take it from there. All right. I think we can stop recording now, and that's it for today's class.